Okay, so this is number 2. I get to make a correction on notes, by the way, I'm just noticing it. This is going to be y prime, and this is y double prime. All right, let me go through that with you. But I have to make it correct. I have to correct this because there's an error. Let's write this down. So y equals, and that's going to be x cubed minus 6x squared, and then, let's see, plus 17x. Let me put down the first derivative, relatively simple. It's 3x squared minus, let's see, 12x plus 17, all right? Let me put down the second derivative. That's going to be 6x minus 12, all right? So, what I'm going to do here is just, I'm going to look at the graph they've given me, and they've given me a graph that says figure 49 at page 135, and I'm seeing this over here. And what I notice about the graph over here is that, it definitely looks cubic to me. I see this over here. And they want me to indicate points on the curve that they call transition points. So I'm going to look for, certain things. One thing I want to look for is there any extrema on the curve? Because maybe they didn't give me the complete picture. So one thing I'll do is y prime ever equal to 0. Well, let's take a look at that. And I'll write that down for you. 3x squared minus 12x plus 17. Well, I can't factor out using finger numbers, so I use quadratic formula. Let's see, twice a, which is 6, right? Then it's going to be the opposite of b, which is 12, plus or minus, it's always the tough part. The b squared, 144, minus 4, times a. Well, 4 times a is just 12, and 12 times 17. What do I know about over here? There's no real solutions to this over here. It's complex, no real. I should say not real. It's complex. So I'm going to say there's no place where it's changing its sign. All right, so I'm not going to worry about that. So I'm going to say there's no extrema. I can't indicate that. Now I'm looking at this over here. I'm going to say there's a point of inflection, POI. And we're going to look at the second derivative now. When does that occur? Well, it occurs at 2. To the right of 2, it's positive, which means it's concave up. And to the left of 2, it's negative, which means it's concave down. So I have one point of inflection, POI. I'll indicate it on the graph, by the way. It's at 2. And not that I want to compute it, but it would be f of 2. And this is what f is. I'll write that down for you. I want to go to the graph and look at it and see if that's true. And this is where 2 is, right over here. And I'm going to say, as I stated, to the right of 2, it's concave up. I definitely see that. This is concave up over here. And to the left of 2 is concave down. So there's only one transition point I'm putting over there. It's a point of inflection, and it occurs at where x equals 2. And I see that being indicated right there. Thank you.